All right, question 1. Okay, I know that sine of theta is 7/11. So in my triangle, I'm just going to draw it over here inside. Let's just have C, A, B. I've got theta right there. Okay, I know that sine is opposite over hypotenuse. So I know that this side length and this side length, my opposite is 7, my hypotenuse is 11. Now I need to find my third side length. So I'm going to use Pythagorean theorem to solve my third side length, which would be 11 squared is equal to 7 squared plus this side length. I'm just going to go x squared, okay? And you're going to plug that into your calculator, see what you get. When you plug that into your calculator, you should get x is equal to 8.5. So now I know my 3 side lengths. I can find any trig ratio. So cosine for theta is adjacent and hypotenuse, so I get 8.5 over 11. Tangent is opposite over my adjacent. Secant is SEC is secant. So I know that's the opposite of cosine, so that's going to be 11 over 8.5. Cosecant is my reciprocal of sine, so I get 11 over 7. And then cotangent is 8.5 over 7. So we're going to use that same information but solve for my triangle B. Okay, my triangle B, I'm just make it over here. I got sine my theta, and I know that cosecant is 15 over 8. Cosecant is my opposite of sine, and so I have 15 as my hypotenuse and 8 as my opposite. So if I know that this is 15 over 8, I know my opposite and hypotenuse. So hypotenuse and opposite, same thing. So you're going to solve for this side length and do the same stuff that you did up here for part B. Okay, for number 2, there's a couple different ways to solve this problem. Okay, what I'm going to do is that I notice that there is one big triangle here. You could split it up into 2 triangles, find this side length in relationship to this and this, and so on. I'm going to choose the fact that this is one big right triangle. And I know this is a right triangle because this is 90. So that means this side length is, or that degree measure is 90. And 90 and 60 combined going to give me this angle measure of 30. 6 equals 30 is 90. So this is a right triangle right here. If I know that this angle measure is 30, we have this angle measure of this is 90 and this is 60. I know that this measure over here is also going to be 30. Okay, I need to have this angle measure if I'm going to be able to solve for x here. Okay, 30 in relationship to my angle, I have opposite and hypotenuse. I know this is opposite because that's the way my angle is pointing. And I know this is hypotenuse because it's opposite of my 90 degree right there. In relationship to my angle, I have 30 opposite and hypotenuse, so I get sine of 30 is equal to my opposite x over 9 root 6. Could have made that a lot nicer number, I apologize. Okay, how do I get rid of this off the bottom? I need to get x alone, so this is a division problem, so I gotta use multiplication. Multiply by 9 root 6. What I do to one side, I gotta do the other. 9 root 6 multiply. And in your calculator, you're gonna type that out and get x all by itself. Get 11.0. That's your answer for that one. Boom. All right, so my first is always to draw a picture. Awesome about this one is it's already got the picture for you. So we have an angle of elevation of 24, which means that angle down here on the bottom is 24. And we're trying to find how tall is it from the platform up to B. Now remember, you just assume that your eye level is 5.5 from where you are standing. Let's just go off of the platform spot. So you can cross this part out. Okay? And we just need to find opposite of B, or find our B length. Okay? In relationship to my ankle, I know opposite and adjacent. So that means I'm going to use tangent as my solver. So I get tan of 24 is equal to my opposite, b over 1,000. Okay? What I do, I got to get b by itself, multiply by 1,000, multiply this side by 1,000, and in your calculator, just type that out. 1,000 times by tangent of 24, and that's going to give me 445.2. Again, not trying to scale, but if this were to be there, it is 445.2 feet up. Okay, the elevation of the ground is 52,052.80 feet. Use your answer part A to find the elevation of the top of Mount Rushmore. Okay, so down here is 5280. I need to add this number to get up there. So I'm going to take that total, add it to my 5280. So from where I'm standing, 5280 plus 445.2 is going to give me 572 feet. So that's how tall it is above sea level. That's elevation. Okay. All right. These are angle of depression problems. So that means if I'm up here in the plane, that is 2,500 feet above ground, I guess, and we look down and we see town 1. Our town 1 is this x, and our town 2 is our y value. Okay. What is the distance from the airplane to the first town? That is looking for our hypotenuse here. Okay. In relationship to my angle, I know that this whole thing is 25, and that 25 plus this angle is going to equal 90. So what I'm going to do in my calculator, I'm going to go 90 minus 25 to find this angle. I can't use the angle of depression because it's outside my triangle. I need to use what's on the inside. So that's 65. Okay, so 65 in relationship to my D. Okay, I have adjacent and I need to find hypotenuse. So this means I'm going to use cosine. So I'm going to use cosine of 65, because my angle measure is equal to my adjacent, 2,500, over my hypotenuse. Now I need to get d by itself. Multiply d up to get off the bottom. Multiply by d. D is not by itself now. This is a multiplication problem. I gotta divide. So in my calculator, I'm going to write 2,500 or 25,000 over cosine of 65. So 25,000 divided by cosine of 65, I get, oh my gosh, now my airplane is 59155 feet away. Okay. What is the horizontal distance from X to the airplane to the first town? So we're looking for this X distance right here. So we're looking for same thing in relationship to my angle of 65. I want opposite and I know adjacent. So opposite and adjacent means tangent. So I'm going to use tan of 65 is equal to my opposite, I don't know, over 25,000. That's my adjacent. So to get x by itself, I gotta multiply by 25,000. Boom. What I do to one side, I gotta do the other. So I get 25,000 times by tangent of 65. This distance right here is equal to 53,612 feet. Okay. What is the distance from y between the what is the distance between y, the two towns? Explain your process for finding this answer. I want you to do this one on your own. So we gotta find this whole length right here. Okay? And then take whatever this whole length is and subtract it from here. Got it. Alright, so this one's really important, and you'll see that here in a little bit, especially tomorrow, because this is going to be a question on your test. Triangles ABC and KLM are similar. Assume that angle C and M are your right triangles, okay? Explain how we know these are similar, okay? When we talk about similar triangles, there's a couple of identifications how. Similar means that they have the same angle measures and that their sides are proportional to each other. We know that these are similar because they match angle, angle, angle. So we have 3 angle measures that are exactly the same. A and K are the same, B and L, and C and M. They're the same. Now remember that C and M are my right angles. Okay? What ratio is equivalent to AC? Okay, so this side length over here is little a, and this one's little c over here. So I need to use my triangle over here to determine what ratio is the same. I get little k and little n. So my answer for this one is little k, little n. That's simple, right? Okay, what is the ratio equivalent to tangent of B? Okay, in relationship to B, this is my hypotenuse, C. Okay, I get B and A. My tan B is always going to be opposite and adjacent. So in this case, tan B is little b over little a. And in relationship here, I need to know the same thing. That's little l and little k. So those two things that are the same are L and K. That's simple, right? And explain why trigonometric functions are dependent on the angle and not particularly the side lengths. Okay? Remember, your answer to this one is that sine, cosine, tangent, all those trig functions are measures or functions of the relationship of the angle to its side length. So a sine of 90, no matter if it's on this triangle or this triangle, is going to be the same no matter what. A sine of 30, whether it's on this triangle or this triangle, is going to be the same. So on and so forth. Does that make sense? Awesome. All right. So these are example questions for your review that hopefully will help you with your review and your test tomorrow.